All right, students, we're going to actually be working on a task that is in your PDF. And so you're going to want several pages out. I think hopefully I put the page numbers in here for you. Let's see. Yes, okay, perfect. So the PDF pages actually goes to 26. Some of them are blank. Page 21 and 22 is the task we're going to be following and writing our answers on. Page 23 is going to be cut in half, and we're going to be using this in the task. You'll need a pencil for that part. And then page 25 is the graphic organizer, and we'll fill that out as we complete the task. All right. So this is learning about the sine inverse and cosine inverse, and we are going to kind of explore how this works. So the first thing you're going to do is you're going to grab that page with the graph that you have there of sine. So take a look for that sine graph, and let me just peek. Okay, so this is what you should be looking at right now. So for this graph of sine. So when you get that, I'm following along here on the task card, you're going to thickly shade with pencil the curve for sine of x. So you're going to take your pencil and you're going to really trace this really nice and thickly. And you need to use a pencil. And you'll see why. Oops, that's a little crazy looking. Okay, so we'll just pretend like this is a pencil and you're shading super dark. Okay, you're going to fold the line, fold the paper rather, along the line y equals x. So this is our line y equals x. So go ahead and fold that and press down. And we're using the line y equals x. It says, why do we do this? If we were doing this algebraically, so we have a function, which would be x comma y, could be a point. And then if we wanted to do the inverse, and you just had this on some homework too, the inverse, we would reverse order. So it would be y comma x. So remember when you've solved for the inverse, you switch the x and the y and you solve. Same type of situation here, but we're going to do this visually. We're going to fold it on that line. Okay. Let's see. Open your paper and look at the new graph. So first, let's see here. Okay, thickly shade. Okay, hold on. I skipped a little step here. Once you fold it, you're going to be able to see your drawing. And what I did is on this white part of the paper, I could see my pencil. And so I just pressed down like this, and I flipped it and I pressed down like this. Okay, so I pressed both of those down. Now, look what's going to happen when you open this up. Hang on one second. My thing keeps going off here. All right, when you open this up, you're now going to see this. This is from when you drew on the other side. Okay, this is your inverse sine. This was the original sine curve. You drew with pencil on that. You folded it in half. And then press down, and where you saw, again, when I look over here, if you can kind of see, you can't really see through, but like here you could even see through, right? Some of that graph there you can see a little bit, okay? So you're looking for where your pencil is, okay? And then you're going to really darkly put your line on there, and then when you open the paper back up, this is the new part that you're going to see. Okay, this is the inverse of sine. Now the next question is asking, is the inverse of sine a function? And if you look at this pink curve, I'm hoping you notice that when I plug in, let's say, a value, I'm getting more than one output. So an input, let's say, is this, and I'm getting an output here, and guess what? It would keep going up and down forever. So this is not a function. Okay, so thinking about the unit circle is the next part. I'm going to move back to the task card where you're writing down some of this information. Okay, let's see. So this is saying, is it a new function? No. And you can obviously write a little more out. I'm going to try not to spend a ton of time here. There is, so for an input, we have more than one output. Okay, so we know, we see the inverse sine, we see it is not a function. All right, here's the next thing. This is asking us, so this is our unit circle, which two adjacent quadrants represent all possible values of sine? Now remember, sine is going to, when you think of when you're graphing sine, the outputs oscillate between 1 and -1, right? We're up here at 1 and down here at -1. So if we think about, let's say we look here and here. Well, that only gives me outputs from 0 up to 1, so that's not going to work. What if we wanted to do, let's say, here and here? Well, that only gives me outputs 0 to -1, so that's also not going to be real helpful. But if we look here, notice we get outputs up at 1 and outputs down to -1. So this is the two adjacent quadrants. This is going to work really nicely for us. So the quadrants here are going to be quadrant 1 and quadrant 4. Okay, what are the angle measures? So the angle measures for this question here is going to be from -pi/2 is less than or equal to theta, which is less than or equal to pi/2. That's the angle measure. So we're talking here the outputs, the actual angle measures go to negative. This is going to be your -pi/2 right here at the bottom. And then we're going to go up, 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 up until we hit pi/2. Okay. So label and shade this on the circle. Okay, so that's kind of sloppy, but that's shaded. What is the actual domain and range of the inverse of sine? So that it is a function. And we're going to be writing this on our little graphic organizer. But our domain is going to be -1 to 1. And our range is going to be -pi/2 to pi/2. And that's our restriction so that we're able to have a function. Okay, so darken the patch or the portion of the curve in another color that corresponds to making this a function. So I'm going to go back now and show you what I did here in a different color. So this is -pi/2 to pi/2. That's the range. And this is -1 to +1, and this is the little bit that we can now say is a function. Okay, so that is the inverse of sine. Let's go ahead and fill in this graphic organizer. Now, when you use your calculator and you type in inverse sine, it is only going to give you outputs that are between these values. That's it. Okay, because it's only going to be dealing with this little part of the curve in blue. So for the inverse sine, our domain is from -1 to 1. The range is from -pi/2 to pi/2. The graph we're going to show is, let's say, pi/2, -pi/2, and we'll say 1 and -1. And let me get a different color for this. Down here, up here, and up here. So it's kind of like that. And then for the unit circle, again, we're using this part right here. Okay, so that is our inverse sine. Now, let's take a look at task 2. So this is saying when Zach solved the equation, sine of x equals radical 3/2. He explained to Sean that he was undoing the sine function by applying sine inverse to both sides of the equation. Sounds logical. So his answer was x is equal to the inverse sine of radical 3/2. So let's go ahead and make sure your calculator is in radian mode. And I'm going to check mine real quick. Oh, I was in degrees. Okay. So now we'll go ahead and hit inverse sine, and we're going to put in the square root of 3, and we will divide by 2. And let's see. Oh, I made a mistake. Hold on. Sorry. Okay. You are most likely done by now. Okay, square root of 3, and then close that parenthesis. Okay. So we should get, for this, approximately, so x is approximately 1.047. Now this says verify the answer is pi over 3. So I'm just going to actually type in pi divided by 3. And we get the exact same thing, about 1.047. Okay, this says Nancy knows the answer is not complete. She knows 2/3 pi is also a solution. Let's think about this. So sine is positive here and here, yes? And we're looking for sine of an angle that is equal to radical 3 over 2. Okay, so we'll go ahead and do our pi over 6, pi over 3. We know this is a half. We know this is radical 3 over 2. So that is telling me the angle we're looking for is this pi over 3, which is what we wrote already. Okay, and this is what he got, is this pi over 3 right there. Okay, but notice these are at the same height. Oh my goodness, that looks terrible. These are at the exact same height, which means this angle is also a solution. And guess what? If I start here and I go all the way around to here, guess what? That's a solution as well. I'm going to make this picture really messy. If I go here, around and around, boom, I'm there again. So there's actually an infinite number of solutions. Every time I hit here or here, that angle will make the equation true. Okay, so, and remembering that this is your reference angle here is pi over 3, and this is pi over 3. And that's what we talked about in our last unit, and we're going to continue here. So the complete solution for this, x is, just like Zach said, it is pi over 3. That is correct. But then guess what? If I add a whole revolution times any integer, I'm going to get to that same spot. So that is an infinite amount of solutions. And guess what? This Nancy is exactly the same. She has the same correct answer, but it's now going to be this 2/3 pi. They both have correct answers. Okay. And again, if we do a full revolution forward or backwards, we're going to get to Nancy's exact same spot. This is your complete solution. So when we want to find out what is this angle measure, there are an infinite number of spots that are going to make this true. Okay, there's a difference between these two questions. So visual differences. There is no variable here. And I'll tell you right now, this is something that gets students very quickly. There's a lot of confusion with this. This, we need to solve for x. This is evaluate. Evaluate. So it's different if you're solving or you're evaluating. This is a huge piece that we need to be very careful with and make sure that we know the difference between those two. Okay, so for this one, if we're solving for x, we could take the inverse of both sides. That's fine. So x is the inverse sine of 1/2. Okay, we can also think about sine of what angle is equal to 1/2. Well, let's think about this. If we're looking at sine, this is going to be our pi over 6. This reference angle is pi over 6. So this angle is 5/6 pi. So x is going to be a 6th pi plus a full revolution, and x is also going to be 5/6 pi. Oops, yeah, plus a full revolution. And so k, and I didn't write this, I'm going to go back and write it. This is where k is an element of the integers. So this means k is any integer. Positive, negative, 0, doesn't matter. It'll get us to that same spot. Now let me go back because I did not write that. We can't just have a variable in here and not say what it is. So where k is any integer. And for our abbreviation, you can just say k is an element of the set of integers. Okay, now this is just saying inverse sine of 1/2. If you went ahead in your calculator and typed this in, let's see, let's do inverse sine of 0.5, and we would get, so inverse sine of 1/2 is 0.524, approximately. That would be our value. And we also know, so this would actually be the approximation if we used a calculator, but for an exact value, it is equal to pi over 6. And this is done. There is nothing to solve for. There's no multiple solutions. You are evaluating. Think about if I said, hey guys, what is 2 cubed minus 4? Okay, it's 8, take away 4, it's 4. You didn't solve anything. You're just evaluating. That's all we're doing here. When you see a variable, you solve for the variable. When you do not, you just evaluate. Okay, you're going to do the same task for cosine, and I'm just going to show you what I have for my results here, and you can certainly fold it and do the same tracing. So this is going to be the same directions as the last one, but we're going to do it with cosine. So here is what you should end up with, and of course, pause and actually draw this out, but you should end up with this. Oops, I got a little farther. Okay, so we're going to go from 0, my highlighter went a little nuts there, from 0 up to pi, that's the range, those are the outputs. And the inputs are -1 to +1. Notice here for cosine values, we're talking about quadrant 1 and 2, +1 to -1, because we're looking at x values. So we're going from 0 to pi. I wrote this down. This is our regular cosine, right? 0 to pi and -1 to 1. We reverse that for the inverse. So let's go ahead and add this to our graphic organizer. So this will, again, for domain, be -1 to 1. The range will be 0 to pi. This is going to look like this. From -1 to 1, we're going to go up to pi. And let's go ahead and write this in here. We have this and this, and we're going to kind of look like that. Again, when you did it and you folded it, you could see it was not a function, same as before. We had to restrict in order to make it a function. Okay, so task 4 is solving sine of x is equal to 0.3. So let's go ahead, and it says use your calculator, find the first solution. So I'm going to say inverse sine of 0.3. So let's show our work here. Inverse sine of both sides. And so x would be about equal to 0.305, let's say. Okay, that is one solution. Again, you are solving at this point. Is this an angle or is this a side length? So what is your thought on that when we're actually solving? What do you think's going on here? So let's take a visual of what's happening. So this is saying that x is about equal to 0.305. 0.305. So this is about 0.3 radians. This is an angle. Okay, now where is the other angle? Because we know there's a positive here and the same positive here. So how are we going to go ahead and find that other one? So we can say, oh, this I know is pi radians. So can't we just say pi take away 0.305? And let's see what we get. We get about equal to 2.83. 0.37 radians. Okay, here's our solutions. X equals 0.305 plus 2 pi k. X also equals, 2.837 plus 2 pi k, where k is an element of the integers. All you're doing here is you're saying, I could get back here if I if I start here at this point and I subtract 1 whole revolution, boom, I'm right back here again. If I'm here and I add a whole revolution, boom, I'm right back here again. If I add 10 revolutions, I'm back here. Same thing at this spot. If you add or subtract another revolution, you will be at that same exact location and get the same exact value. So that is why there's an infinite number of solutions. All right, students, you made it. We will definitely work more on this in class. Please write down all your questions, and I will see you all real soon.